Hello students, today we will see Bode plot of lead compensator. Here assumptions consider Kc is equal to 1 and alpha is zero point 0.1, omega C1 is 1 by t and omega C2 is 1 upon alpha t. So this first plot is already we know magnitude plot and the second plot is a phase plot. In magnitude plot 0 dB is considered as a reference, and for phase plot we are taking phase angle in degrees. So this is a Bode plot of lead compensator where omega max is 1 upon root alpha t. Omega max means maximum phase lead frequency. It is geometric mean of two corner frequency. Next, we will see the deviation of maximum phase lead frequency, that is omega m. So this is our standard transfer function, that is gc of j omega is equal to kc alpha 1 plus j omega t upon 1 plus alpha j omega t. Now the phase angle of lead compensator phi is equal to what? As we already know, this is a transfer function. From this we are calculating a phase angle phi. So phi is equal to what? Angle of numerator minus angle of denominator. For division we are taking a subtraction. So first numerator is what? 1 plus j omega t. So for this angle is nothing but what? Tan inverse imaginary upon real. Imaginary is here omega t, upon real is 1. Similarly minus for denominator equation, tan inverse imaginary part is skip the j part and alpha omega t upon real part is 1, and denominators are 1, so we are rewriting the equation phi is equal to tan inverse omega t minus tan inverse alpha omega t. Now this is a phi phase angle, notation is phi. Differentiate this phi with respect to the omega and equate it to 0. So d phi upon d omega at omega is equal to omega m is 0. So d phi upon d omega, as phi equation is already we know. Now differentiate this with respect to omega, that is d upon d omega of what? Phi means tan inverse omega mt minus tan inverse alpha omega mt, as here we are considering omega is equal to the omega m. So everywhere we are changing omega to omega m, omega to omega m, and equate it to 0. As this is a standard formula, derivative of tan inverse x, d dx of tan inverse x is always 1 upon 1 plus x square. Similarly, d upon d omega of tan inverse omega t is t upon omega square t square plus 1. This is the derivative formula for tan inverse. Now applying this derivative formula, first is t upon 1 plus omega m square t square minus second alpha t upon 1 plus alpha square omega m square t square is equal to 0. So divide t square to this first equation and alpha square t square to this second equation for both numerator as well as a denominator. So first equation what? T upon t square divided by, now this whole equation we are dividing t square, so 1 upon t square plus omega m square minus this equation we are dividing alpha square t square, alpha t upon alpha square t square divided by 1 upon alpha square t square plus omega m square is equal to 0. So by solving this we get 1 upon t is equal to omega m square plus 1 upon t square minus, here alpha gets cancelled, t gets cancelled, 1 upon alpha t upon omega m square plus 1 upon alpha t square is equal to 0. Here equal to 0, that means both equations are now equal, and by solving this 1 upon t gets cancelled, then omega square plus 1 upon alpha t square is equal to 1 upon alpha omega square plus 1 upon t square. So by rewriting this equation we are getting alpha. This alpha is now shifted here, alpha into this whole omega m square plus 1 upon alpha square t square is equal to omega m square plus 1 upon t square. Multiply this alpha inside bracket, alpha omega m square plus alpha upon alpha square t square is equal to omega m square plus 1 upon t square. Alpha omega m square plus 1 upon alpha t square is equal to omega square plus 1 upon t square. Now we will combine this omega terms and this 1 upon t square. So alpha minus 1 omega m square is equal to 1 upon t square minus 1 upon alpha t square. From this equation we are taking common 1 upon t square into bracket 1 minus 1 upon alpha. Then this alpha minus 1 is common here and here. We are cancelling. Omega m square is equal to 1 upon alpha t square. So omega m is equal to 1 upon root alpha t. This is maximum phase lead frequency and we are deriving this equation. This is maximum phase lead frequency. Next, derivation of maximum phase lead angle. Previously we derived derivation of frequency, now the lead angle. We have phase angle of lead compensator phi tan inverse omega t minus tan inverse alpha omega t. Now apply the tan of phi is equal to what? Tan of whole equation. As we know the mathematical expression, tan of x minus y is equal to tan x minus tan y upon 1 plus tan x tan y. Same formula we are applying here. Tan phi is equal to tan of tan inverse omega minus tan of tan inverse alpha omega t upon 1 plus tan of tan inverse omega tan of tan inverse alpha omega t. Tan phi is equal to omega t minus alpha omega t upon 1 plus omega t into alpha omega t. But we know at omega is equal to omega max, omega m is equal to 1 upon t root alpha. This derivation we already previously calculated. So tan phi m is equal to omega t 1 minus alpha upon 1 plus omega square t square alpha. Omega is equal to omega m and this is 1 upon t root alpha. So we are substituting here omega m value, that is 1 upon t root alpha everywhere, and by doing this calculation we get tan phi m is equal to 1 minus alpha upon 2 root alpha. And this is it. So here in this video we completed the derivation of omega m and the phi m. So thank you.